Okay, so we are live. So hello and welcome to the Wrocław and Silesia Jugs. Today our guest is Piotr, Przybył, and we are happy that you agreed to our invitation. It's first of the two parts event. The next one will be on 25th of May and it will be hosted by our friends from Silesia Jug. During this event, you may and you should ask questions because for those of you who have great questions, we have tickets for developers conference, and also we have JetBrains license. During this event, I will interrupt Piotr and ask your questions in your behalf, and I hope you will enjoy this event. And it's all. Piotr, stage is yours.
Okay, that was really quick. I need to admit. Yeah, so we are having this event divided into two parts, basically, because well, together with my friends from both Wrocław Jag, both Silesia Jag, we've decided that that this last release of Java, I mean Java 16, is so big, and if we really want to go deep, I mean as deep as reasonably possible, then it would be basically too much for a single meeting. So that's why it's split. So today we will have some Java features discussed. I mean of Java 16, and after more or less 2 weeks on May 25th, we are going to have the rest. Basically, more or less, this should be split in half, although it's not strictly guaranteed. And yeah, as Sebastian told you, we are really here and not just, to say how Java is cool and so on and to impress you and blah, 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 yada, yada. It's not about being any celebrity and making anything like super duper glorious. We are here primarily to answer your questions. So if you have any questions, please shout them out. Of course, you can ask questions in Polish because we're representing Polish Jugs. So questions will be translated to English. If you like to ask questions in English, of course, that's also super duper okay. And as Sebastian mentioned, the most active participants asking the best questions will be given just because we have three tickets for. Let me switch the screen. We have 3 tickets for developers, which is, as it says here, the biggest interdisciplinary IT festival for programmers in Poland. And at the next meeting, we'll have some free tickets for you for JLove conference. Cool stuff. I mean, even if you're not strictly Java programmer, for developers, they have also other tracks. So I think it's worth attending. So you have a chance to get a ticket if you are active. Okay. So is there anything I should say? I don't think so. So thanks for the invitation, and let's keep rolling. So who am I? Briefly about me. So my name is Piotr Przybył. I know it might be difficult for you because it's in Polish. Nevertheless, don't worry. I'm basically Piotr, or like Peter. Peter, Pierre, or whatever you translate it in your language. This is my Twitter or Telegram handle, so you're free to send me a direct message if you need to. And I'm self-employed on a position called, I call it remote freelance software gardener. So what remote, I mean, I think we know what remote means, right, these days. I've been remote even before the pandemic. Freelance, we know it. And if you don't know what software gardener is, I mean, what's this role, what this person is about, what the person believes, and the principles, basically, you should read the book, the fantastic book, The Pragmatic Programmer. And there's also my personal blog page, softwaregarden.dev, where I blog about various things, usually recent Java, and I also work as a trainer from time to time. And yeah, I've been with Java since like version 1.3, so it's quite a few years, quite a few releases I've seen. And even when I go on holiday, provided there's a holiday, and you can go on holiday, then Java is somewhere behind me. By the way, if you're wondering, yeah, I mean, it's still difficult to get a proper haircut, at least in our part of Poland, because the barbershops were open just quite recently. That's why I prefer this haircut than my previous one. Please excuse me. I have an appointment on Friday, so I still need to wait 2 days. Okay. So there's also a question, who are you, my friends? So please let us know. I always love this big shout out from you about which version of Java are you currently using production. whether it's something like below Java 8, Java 8, Java 11, maybe even Java 15 or 16, please let us know. We'd like to know that. And a little warning before we actually start, a little caveat auditoris. So I'm just a human being, all right? I can make mistakes, like everyone can make mistakes. So please don't assume anything based on this presentation, and verify on your own. Just don't trust talking heads on the internet, verify on your own. And there is always this question. Oh, okay. Maybe just before I go further, the idea for today is we'll try to keep this meeting like 90 minutes, maybe a bit longer. We'll see how many questions you have, and we'll try to cover basically everything except records, because records are so huge and so game changing that I think this is the best way we could decide. We could divide this into these two meetings. So we'll see records at Silesia Jag, and today we'll be trying to discuss everything else. Okay, so that's the plan for today. And there's always this question: shall I migrate to Java 16 or stick to the latest LTS? And I like quoting, I think, Ron Pretzler, if I'm not mistaken. And Ron used to say, I mean, he's one of the biggest and greatest personas behind Project Loom. And he used to keeps saying that LTS is nothing more but a business term. So it's a business promise given by a company or a few companies that they will support given version of a software for longer than usual. And that's it, basically. There are no more technical differences to various Java versions. And so the question is, it depends, right? So if you're in the cloud, most probably in many public clouds, you don't have the latest Java release because reasons, right? But if you're hosting stuff on your own, or if you're running, I don't know, your own containers and so on, then of course you can upgrade, provided all the features you need are still in Java, and I'm basically trying to point here to SANMISC and safe. So that's usually the biggest reason, like some off-heap operations and so on and so on. So if your software runs on the latest Java version, I think it's the best approach, the best attitude or mindset, if you will, to stick to the latest Java version, basically, not to delay too much, because you can also benefit from new cool stuff. I mean, not only from Java 16, and I don't mean that you should rewrite your code, of course, but that you can actually benefit from other updates, like performance. For example, we have this new cool Java, garbage collectors from Java 15, for example, and so on. And of course, maybe it's worth skipping incubator modules or preview features in production environment. Maybe it's not the best to use them. Nevertheless, everything else should be, if it's worked, just go and update. And please remember that migrating to when it comes to migrating to these non-LTS versions, that sometimes you need to face this LTS, choose someone who's going to be a de facto LTS vendor. Like, for example, Azul, as far as I know, is supporting every second version of Java. Or sometimes you may need to face a thing called like support cliff, right? So there's this slight risk that something will be cut off from your version, but so far it didn't happen that much, I think. I mentioned cloud providers, and yeah, if you're going for production features, it's if you're releasing an on-premise software, it might not be the best idea, because then your clients need to enable it. I mean, the people who are running your software, and you also need to recompile your software to actually match, because this is the philosophy or the mechanics or preview features, that the version of preview feature needs to match the version that was compiled and the version it's running at. And also, please remember that we can get these benefits, like from better performance, new GCs, new syntax, of course, and so on. And there's also this better feedback for Java team, or for your team, for example, whether it's worthy or not. Like, maybe you could go ahead and migrate a few microservices, because why not? Maybe these are less critical, less complicated, and then you basically eat this elephant in small pieces, because we have like a running joke in Poland, or that's a kind of a riddle for children: how do you eat an elephant? And the answer is piece by piece. So maybe instead from jumping from Java 11 to Java 17 in September or autumn this year, maybe it's worth to try to keep with Java like every 6 months, to upgrade it, and so on and so on. And please stress me this one thing, that neither these LTS releases or preview features are monkey soft or banana soft or anything like that, okay? They are tested. Technically, there is not much difference, or I can't tell if there's any technical difference between various Java releases. And there's, of course, this small asterisk regarding incubator modules or preview features that they are subject to potential change. And that's it. Okay, that's why maybe you don't want to go for preview features for in your production environment. I think they're mainly useful for various framework or library maintainers because they can prepare for this feature to be released before it's actually released. And we saw that for example for records. Okay, so Java 16. As for Java 16, it was released like on March 16th. And it had 17 jabs in total, so it was quite a rich release, I need to say. There are release notes. I encourage you should read these notes and hopefully understand them and so on. And that should be it. However, this talk, this presentation is for you. It should be rich with demos, so you should understand it perhaps better than just reading changelog or documentation. We have new syntax like records or pattern matching with instanceof. We have new or still preview features like sealed classes. We have incubator modules like foreign MAME access or foreign linker or vector API, basically Project Panama. There are some jabs regarding infrastructure like Java migrated to Git and GitHub, and there are also new ports or new builds, if you will, like for Alpine Linux and Windows Arc 64, and of course there are other features not always as a part of a jab. And this is another way you could see, or we could see, the jabs released in Java 16. So we have 3 jabs from Project Amba. We have 3 jabs from Project Panama. We have 1 jab from Project Valhalla, which is like kind of preparing us for Project Valhalla. And we have still 1 jab from Project Jigsaw, thing modules or modularizing JDK and perhaps applications. And so this is about like cleaning stuff, and this is like also cleaning stuff but preparing us for more. Amber is for more like syntax, and Panama is for native stuff like native calls, native memory, and so on and so on. And of course, we still don't have Loom. Like maybe you know when Loom is going to be officially released. I can't tell you that. So we have these jabs. There are 8 jabs like these. We have another jabs here. Okay, so this is it. Thank you. Of course, this is a bit of troll. We're not going to finish here. It was just like agenda for today, like detailed agenda, what we're going to do today, and of course on May 25th. So briefly about preview features, because some of the stuff we're going to discuss, namely sealed classes, are still preview feature, and they are implementation of JAP 12, and basically they are about enabling preview feature using this -- enable preview during compile time and at runtime, right? So we have to explicitly opt in for these features to be enabled at compile and runtime. Okay. So this is how we enable them, and I talked about this quite a few times. So if you're interested, because I don't think it's worth wasting our time, there are some technical caveats, or maybe not caveats, like limitations or requirements or conventions you should follow. And these are the slides for you describing this more, and this is a video describing that more. By the way, the slides, the code, everything is online, so you'll be able to fork this repository and experiment on your own. So yeah, we had these 2 infrastructure jabs. So they were about migrating from Mercurial to Git and eventually GitHub. So now we can fork OpenJDK and quite easier. Like in an easy way at GitHub, and I don't know, make your own build if you wish to, or something like that. And another like kind of, it's not infrastructure, it's just now the parts of JDK that are written in C++ can use language features or C++ 14. Okay, so if you're developing in JDK, that's something that, I mean, the JDK itself, right? It's something that it's potentially interesting for you, and it might require some changes to your build, basically. Okay, and we also have these new builds for Alpine Linux and for Windows. And I mean this ARC64, of course, architecture. And when it comes to this Alpine Linux support, I'm not going to show you that, but there should be a JEP, and it's very interesting if you really have to go for a small Docker image. For example, if you need to have something smaller, then you can go for this build, because it should reduce the size of the image. Or for example, if you need to run it on, I don't know, the light bulb or Internet of Things devices, something like this, then you can go for a smaller Java basically. And as you can see, there are some numbers here, so you can get such a small numbers if you really need to. So that's the reason behind this JEP. Okay, I don't see any questions so far, and that doesn't surprise me. Okay, so let's go for warnings for value-based classes. This is now a standard feature introduced in Java 16, of course, like everything else. And this was implementation of JEP 3.9.0. And let's talk about these value-based classes, what they are in the first place. So these are these classes where we don't care about their identity, like technically like object header and so on and so on. What we care about is the value they keep inside, right? So an example for that might be a string, for example. We hardly ever check if a string is identical to a string like this way. We rather go for equals this way, right? Also because of string deduplication and so on and so on. And it really doesn't matter where the string was instantiated or what's the current address of this string, like the reference and so on, where is it located in memory. We don't care about that. We care about the actual characters kept inside, okay? Because we value the value. Although string is not a value-based class, I was just trying to give you like a grossly oversimplified explanation what that could be, thought of. And these classes are kind of wrappers, we could say, because they wrap this value. And one of the other constraints is that they are immutable. So once created, a single instance cannot be mutated, like the value inside cannot be changed, pretty much like in string, right? And they should be constructed using factory methods, not constructors. And because we don't care about their identity, but we care about the equality based on the value, then we should be able to replace one object with another object, because we don't care about, as I said a few times already, their identity, but their equality. Okay, and that's important to understand here. And there's a description. There's a kind of a, I don't know, maybe it's not formal, but it's like an official description. It changed slightly from Java 15. So as you can see, it says everything pretty much the same as I just told you. Okay, and we have some examples. We have some actual examples in JDK 16 now. So all these integer-rich types are value-based classes. All these optional, like optional double and so on, are also value-based classes. Maybe not all, but quite a few, or I should say rather many classes from Java time are value-based classes. Because let's say when you have a duration, right? Let's say we have a duration of 1 hour or 1 hour and 12 minutes. So it doesn't really matter where is it located in the memory or something like this. What really matters, it's 72 minutes, right? This is what matters. So we are about the value. And the classes implementing or returned to the callers of list of, copy of, like set of, copy of, and map entry and map of, and so on, they are also implementations of the returners. They give us back the value based classes, and pretty much everything else annotated as value based. Okay, and because of their nature, these value objects shouldn't be compared for identity, right? So they shouldn't be compared using like double equals, and they shouldn't be created using constructors, but factory methods, and they shouldn't be used for synchronization, because synchronization, the monitor object model implemented in Java and so on, relies on the object identity. And this JEP is to make us, the Java developers, like be prepared for the incoming of the Valhalla project, because Valhalla project, and now again it's going to be like very oversimplified lie to children. Okay, like you explain to children that sun is like a big ball of fire, for example, when they are 3 or something like this. So I encourage you to go for Valhalla's documentation, because it's described better than and in bigger details. It's just Valhalla is about making the objects of many classes, including our classes, like headerless, to put it simply. Because when you have, for example, an array of 1 million objects, do you really need 1 million headers if we have object of every if every object is exactly of the same class, instance of the same class, it doesn't really matter, right? Because what we care about them is like values. So Valhalla, in other way, is to allow us, our classes, to become like the primitive types, for example. So like the small integer, for example, it doesn't have like identity, right? We don't call like synchronization, for example, a small integer, and shouldn't we also shouldn't be doing that of int integer, because it's a value class now as well. So what they have now is that the constructors are deprecated for removal, and when we enable this flag for Java-C, then we'll see the compiler will show us that we are synchronizing on value-based objects, and we shouldn't be doing this, right? Because in the future, when Valhalla comes in, this would be totally impossible. Okay, and provided when you have like code from third-party vendors like libraries or I don't know, another team or something, and you're using that, then you can also check for this at hotspot. Okay, so when we go for a hotspot for this switch or for this switch, I mean, these are the same except the value 1 or 2. Then this is like a soft one. It will only log that, hey, Mr. Developer or Mr. Administrator, you are running a piece of Java code which is synchronizing all value-based object, and this will be like making your program go belly up. Okay, it's fatal. It will terminate basically. Okay, so let's see that in code. I should have that in code. Let me find this. It's here. Please chat, please let me know if the code is big enough, or should I go for this pesky presentation mode, because this might be quite okay. And by the way, you also see when I'm currently in the code. Okay, so we have a little demo for value-based classes of Java 16. And as you can see now, all these constructors are deprecated for removal, right? So when I go here, see, it's deprecated since Java 9, and now it's also deprecated for removal. So that's why we see this. I hope you can see that this red line crossing through long. Okay, and then when we try to synchronize, okay, on such value, then what we see, even IntelliJ, it warns us, okay, that we shouldn't be synchronizing of an instance of a value-based class, because currently it still works. It's like a warning that it's going to blow in the future when Valhalla is GA basically. And then what we also do is this nasty thing that we compare various instances of longs, and I mean the big longs, and as you can see, it doesn't raise any warning or anything like that, because this is the way we actually should be creating big longs if we really have to. Right, I mean, apart from auto boxing and stuff, of course, but when we desperately need to do that manually. So let me run this piece of code and let's see what happens. Okay, let's see what happens. Okay, let me bring the terminal back. Okay, so as you see, I didn't have any warning at runtime, right? And why? Because I didn't go for that. So let's go for this diagnostic option. Let's modify this run configuration. And that should be as VM option. Okay, so let's go and let's run it again. right? So now you can see, and because I used 2, I only receive a warning that I am here synchronizing here on in this line. Should be like line 29. See, in this line I'm synchronizing on a value based of an object of a value based class. I think that's the proper description, and we shouldn't be doing this. Okay, so this is the warning, and that's pretty much it. And when you compile the code, we will also see similar warnings. It should be. Let me check if I have that in POM. It should be maybe not this one, because I have like a parent project. Sorry, POM XML. Yeah, then we have to go for all these warnings, or this synchronization, something like this, right? This is what I shown you in the code. So I mean, normally we shouldn't be doing this. We shouldn't maven clean, right? But let's see if it works this time. MVN clean. I got it. Yeah, I know. It's just I want to use a terminal. MVM clean compile. Okay, let's see how it works. Oh, it doesn't compile. Okay, we're still failure. Why is it? Oh, yeah, I know. Sorry, because Java version C, I'm using Java 11 here. So let's use Java 16. That should work. No, I don't. Just switch Java version. Now we have Java 16, and let's go again for this clean compile. And see, I have quite a few warnings here about like other features being preview features and so on. But the warning I should be after is sealed events. Again, sealed events. Somehow I can't spot it right now. But it should be. Sorry, I'm just a bit confused. Nevertheless, this is the way you can go for warnings. For example, when you try to compile using Maven. Oh yeah, this is it. This is the warning, right? See, this is the warning. Exactly the one. So it says that the long has been deprecated and marked for removal, for example. And this is because I made this call. So even if your IDE doesn't show you that, your compiler would do that. Okay. So maybe it's a good idea not to ignore what your compiler is trying to tell you. Okay. And I think these warnings from Project Valhalla are really worth zoom, please. Okay, are really worth to take care of. Okay, do I have anything else on that? Yeah, and of course you can also go for a dep scan, because you can scan the dependencies using this tool, like jars, basically, if they're calling any code that's deprecated for removal or misbehaving, basically. Even if you didn't compile, you just received like a bytecode packed in a jar. Okay. Do we have any questions regarding this part so far?
Yes, we have two. First one is it something like data class from Kotlin?
I don't think so. I mean, no. I don't think so. So it's kind of some compare records to data classes, and data classes and records most probably will be able to be so-called value-based classes or value objects. Like they could be acting like a primitive ones, for example, when packed into a Java array, but they are not that, I think.
Okay, so the second question is about synchronization. Is it applicable to mutex or semaphore-based implementation?
I don't think so. I mean, I or maybe I shouldn't say. I don't know. I didn't check that. Because if we have like explicit mutex or semaphore, then we are going away at least from this direct synchronization module, right? Synchronization model implemented in Java, which is based on monitors. And I think this. I mean, I don't know which classes are we talking in particular, but it might be that because these models of semaphores and so on are like can be implemented using monitors and vice versa. So if they're using synchronization, then it depends what's inside. I mean, what do we synchronize? And this is, for example, when we create like a lazy singleton, okay? And sometimes we to make it like super duper safe or as safe as possible, we are synchronizing on an object inside. And in case, for example, this object is like long, it's not going to work. You need to synchronize on a plain object, for example, for that. I'm not sure if answers the question, but I'm also not sure if I get the question. Sorry.
Okay, so it's last question and it's all.
Okay, so let's continue then. Okay, so next JEP about warnings, and I decided to go for these, let's say, warnings JEPs in the first as the first ones, because I think they are the most overlooked one or underappreciated, something like this. So there's another JEP from project Jigsaw. It's about a strong encapsulation of the JDK internals by default. Okay, and this implementation of JEP 396. And if you remember, or if you don't remember, modules were introduced in Java 9, and they brought us this warning about illegal access, or basically speaking the concept of illegal access itself. And some people suggested, especially I would say some not so eager to work library maintainers or maintainers of some libraries or frameworks, which are like, I would say maybe perhaps even misusing the Java, like the Java is open, object oriented language, at least to some extent. They used to say that these are just warnings, okay, just ignore it. And the worst thing about this advice is that some people decided to follow this advice, okay? And now it might be problematic, because if you decided to ignore this warning and your application was running using Java 9, 10, and so on, up to 15, it won't work in Java 16. And I'm going to show you why. Because illegal access was promised to be temporary, okay? So it was said like, okay, we have this switch of illegal access, and for now it's set to permit. And even that alone was like an argument for many. Okay, yeah, it's like if the default is permit, then it's permitted, and it's nothing that bad about this illegal access, right? I mean, despite it saying illegal access, like people didn't care much about the illegal part. They were more about like permit, okay? And now in Java 16, the illegal access is switched to deny. I mean, this is the new default. And what's more, illegal access itself, I mean, the switch is now deprecated for removal. So we are still able to go for like all these 4 values, because we have permit, we have warn, we have debug, and we have deny. And in future, we won't be able to switch to any other value, okay? So for time being, we can go for permit, although I don't recommend that. And what should you do, I think? So basically, it's about the illegal access is caused by this deep reflection. And by deep reflection, I call something when it's calling this method set accessible true, okay? It means you're trying to access something you're not meant to, or rather, your code is trying to access something it's not meant to. Like, for example, non-public members from the other package, right? And when you're not inheriting from that class, for example, or so when you try to make a method accessible or field accessible, this is the summoning the demons of deep reflection, as I call it, basically. So what should you do? Ideally, you should eliminate all these calls like this, right? And update your libraries. And if the maintainers of libraries say that they won't do that, maybe you should switch to another library, and so on and so on. Basically, eliminating the deep reflection and illegal access is the best thing. Another thing you can do is you can switch to illegal access, and then you can go for debug or warning. The difference is that, I mean, they emit this warning every time, is that debug also gives you a stack trace, okay? And based of this output of these warnings, you can add various add opens clauses. So you are kind of like legalizing the illegal access. So saying, okay, I know this access is happening here, but I think it's okay. Please don't stop or don't warn anyone. Okay, it's okay. You can like bless it perhaps. And the worst thing you can do, I think, is to switch manually to illegal access permit, or you can just stick to Java 16 and keep producing legacy code for future generations, okay? Because it's them who's going to care about this, not me anymore, okay? And why I think it's also dangerous, let's go back to this JEP. I don't think, I mean, well, let's see, maybe I have, sorry, let's go here. Yeah, navigation, okay. Let me try, if I remember the code of this, it was JEP 403, I believe. Yeah. So this is still a candidate JEP, so it's not scheduled for any release, okay? But when you read it here, it says that using this command line option of illegal access is still possible from Java 9 to 16, meaning it might not be possible in Java 17, which is, surprise, surprise, released, yeah, September this year. Sorry for my bad haircut, but what can I do about this? Yeah, so as you can see, we might get it sooner than expected, okay? So that's why I would say it might be a bad idea, basically, to go for a why am I seeing this warning for this illegal access permit? Yeah, so what to do, and I used to talk about this quite a lot on during my presentation, Java 11 migrating in a real app. It's available for you on YouTube. Let's just go briefly and see that how it works in code, or what do I actually mean, okay? Because let's say you are using a badly implemented ORM, because why not? Okay, and you see, we could have this deep reflection into an integer, or we can also try to get a deep reflection on an instant, which is also a value-based class now, right? But this is something else we're going to talk about. And as you can see, I'm summoning here these demons of deep reflection by calling this set accessible and set accessible, okay? And of course, this code is oversimplified, but this is like the philosophy of many of maybe not many, but quite a few, let's say, libraries that instead of relying on public API or various decorators or wrappers or something like this, they were instead like were scanning for all declared fields. They making all the fields accessible, storing these fields one by one, and then we can, for example, like deserializing from JSON or from database the same way. Okay, so what we can do, so what happens basically if we call this code, yeah, let me go for this, maybe let's do something like that. Let's go for terminal, right? And which version of Java do I have here? Version, see, this is this version. And let's go for Java, so I have Java 11, not the last one, sorry. But let's go. Let's call this program, right? And see, it used to work, right? Or it still works in Java 11, and it will work using Java 11 like forever. For example, provided you will work in with Java 11 forever, which might not be the best case. It's just this warning, right? And many said, yeah, ignore this warning because it's not working. And of course, to like eliminate this warning, what we could do is we could go for these add opens clauses, and of course they can be written into like option files, which are like flat text files. I mentioned that in the presentation I'm showing you. And then when you can like legalize this access, this illegal access, and this other illegal access, then everything is okay, right? You see no warning. It's just, let me again switch to Java 16, right? Use Java 16. Sorry, and let's check. We have Java 16 version. Yeah, it's 16. And now let's run this code again without these add opens, okay? See, it doesn't work. I mean, it works until the point when it reaches this first illegal access, because now illegal access is set to deny. And now you can't just happily ignore this warning, right? Something has to be done if you want this program to be running. So as I said, the worst thing you can do is go for illegal access permit, because it says now, you see, is deprecated and will be removed in a future release, and that might be Java 17. So as you can see, it's not a way. You can go for this add opens, or maybe we should analyze this code and let's ask ourselves this question: shall we really be getting like the bytes actually stored in a string using deep reflection, or maybe just maybe we should go for something like this: input dot get bytes, and you can like choose the encoding or car set you're after, right? So maybe even something like this to get the default one, to get these bytes instead of this deep reflection. Okay, and maybe for these instance, again, we shouldn't be going like for accessing seconds field or scanning every other field. Maybe we should be going for something like now seconds, like get epoch seconds, and then nanos, and then maybe we should be recreating this object using instant and one of the factory methods, for example, like of epoch seconds, right? Maybe this is what should be doing instead of like deep scanning and deep reflection and so on. So this is the way to handle that, and it's of course just a little simple demo. It's just to give you the taste what might happen if you try to run a program like that in Java 16 and maybe in future versions as well. Okay, is that all, or do we have anything else? I mean, do we have any questions for that, Sebastian? Hello?
No, there is no questions. So there is one just thought that maybe it's a good reason to not use those tools who use deep reflection, but it's kind of philosophic question.
Yeah, I mean, I kind of keep saying that this deep reflection, it happens when you basically ignore the object-oriented programming principles, right? So sometimes it has to be done, but it's usually should be done by library maintainers. If we do that, it like, let's say, client code or application code, I think it's a kind of a bad smell, and we shouldn't be doing that.
There is a question just show up. Is there any way to detect which library used deep reflection?
The easiest way is to go for like illegal access debug. Maybe I'll switch to this screen. I would say the easiest way is to go for illegal access debug, and then you just, for example, run all of your tests or your test scenarios or something like this, and then you collect the stack traces, and based on these stack traces, you can see who's trying to misbehave, right? Just as we saw here, right? So as you can see, it says that here, like in this method, this is my code, and you can see like the file and the code. I'm trying to call this set accessible, right? So this is like this can point you here, because these things happen at runtime. So I'm not sure if there's any way like to static code analyzers or something like this to help us. That's why I think the best way is to go for this illegal access debug or warn, whatever suits you. And then if you see, we have this stack trace, and this stack trace has like a full package name and so on. So I think you can pretty easily identify which library did that. So that's basically, I mean, the TLDR version, how to detect that, or how to upgrade to like above Java 8, and how to ultimately prepare your code for like Java 16 and later. Right. So this is what I would suggest. Okay. So if we have no more questions, I like the comment from Bartek. Try to run it on Java 16. Yeah, if it doesn't run, and of course there's always this question of these scenarios, right? Because it might be happening in just one feature, and if you don't get for that feature, you won't know unless someone goes. But then with Java 16, with the default settings, you surely will notice that, because the application will go belly up, right? It will terminate. It will know. You will know that it's just that the deny stops when the first illegal access takes place, and debug keeps working. But it also, just like deny, provides us with stack traces, so we can basically figure out when bad things happen. Okay, records, as I told you, records are for the next meeting because they are really like a huge thing. I think they might be a game changer, and definitely they are something you cannot ignore, or Java ecosystem won't be able to ignore, just as we weren't able to ignore generics in long term, just as we weren't able to ignore enums, we won't be able to ignore records because, like, for example, this feature, maybe it can be ignored, like you can code without it, or if you like library maintainer, you might basically not care about this. Okay, but records are something different. Okay, so pattern matching for instanceof. Again, there's a JEP. I think you should read it. And what is it about? It's about this boilerplate code. Maybe I should switch to code because we should have code for that as well. Yeah, it's smart casting. Yeah, this code. Okay. So we'll see the code in a minute. Okay, and what is it about? I see and everybody sees that, like, Java in this very case was quite verbose, right? Quite ceremony, because not only I'm matching here this object I have, if it's an integer or not, then when the match was successful, then I can just double it or something like this. Then I need to tell the compiler again, hey, Mr. Compiler, please take this integer, this object, cast it as an integer, and then start as an integer. So see, integer, like it's quite a ceremonial code, right? And it's, for some, it was kind of like absurd. Like, if you already know it's an integer, why on earth do I really need to cast it on integer again? So this is what we can do now in Java 16. I mean, this was a preview feature in last two versions, and now this is like a standard feature. Okay, so we can now here, after this class, put an alias. Basically, it's an alias. It's a new name of this type. So I don't need to do this casting and this aliasing here. I can just go here for integer, and then the line remains the same. As you can see, I can just double it. Okay, so no problem about that. So it's one less line, a bit less ceremony. And officially it's called pattern matching for instanceof, but I like the name. I think I've heard it from Dr. Venkat Subramaniam that it's a smart casting. I think it's really a smarter way to cast objects in Java. And let's head to our code. Okay, so as you can see, we have this little method, who are you? And this method is basically doing checks. Who this object is, or what this object is. If it's serializable, we're going to say that it's serializable. Then you can see we can go for more sophisticated patterns. Like if it's an integer, a string, then I can use end and go and check the length of the string, and only then jump inside this if statement. And the same happens to integer, and the same happens to long, for example. It's just when I use or, logical or, then of course it has to be wrapped in and, for example, because the or alone won't work because of the circuit breaking and so on. I mean, the compiler needs to be sure that we still continue processing the same alias, the same object of the same class. So let's give it a run, because running code is better than just compiled code, right? Yeah. So you can see, yeah, it's a serializable. So integer serializable, hi and hello has at least 3 characters, right? And then we can check, for example, if we have a positive integer, or we have a long which has at least 2 digits. And then we can also have this method, which is not empty string. And as you can see, it doesn't have any ifs inside, right? So this pattern matching with instanceof is not only about if statements. I mean, if you'd like to just check if, let's admit it, we all have such a method. I mean, sometimes we use Guava, or we use Apache Commons, but sometimes we just, don't go for this import and have this single method. So then we can go for this smart casting, and then we can check right after casting it if the string is not empty, right? So this is it basically. And another thing is let me go back to slides maybe. Yeah, smart casting. So we've covered that. And local variables from pattern matching with instance of, yeah, they aren't implicitly final. So we are able to technically, give them a new value. So they aren't final, they aren't implicitly final. I don't think you should be doing that, like assigning a new value to this alias, but technically it's possible. And they are visible only in the scope they declared, right? So I can go here and print this a long, because it's not this a long, because it's a long, which is a class field right here. And the thing I'm printing here, right here, is not the field, is just this local alias, because when there's the kind of a clash of a name between this local alias and class field, or like object field, sorry, then this one basically wins, right? So it shadows field names, and if I wanted to have like a field name, then of course I need to go for this sorry, not this along, but instance of pattern matching, right? Because it's a static thing. Yeah, so this is how it works, my friends. Yeah, so there's more code if you're interested. Yeah, we've seen this. Yeah, one thing I'd like to emphasize here is, please, just please, because there are many demos showing that this instance of this new construct with instance of is being used in object equals. And I would like to warn you that there are basically two styles or two ways you can write your equals method, right? So it depends on the context, because sometimes we have to go for instance of, for example, for JPA entities, because they are proxied, they are subclassed, and so on. So it's sometimes using instance of is a must. But for many other cases, we shouldn't be using instance of, but just compare the classes directly, okay, unless they're final. So then there's this like, please read and understand the contract behind the equals method of an object. And I also wrote a little entry on my blog post, how not to misuse it or what problems it may cause. So if you're eager to understand more, like with details, please read that article. Do we have any questions for pattern matching with instance of, Sebastian?
We have only one about your personal opinion. Is it cool for you? What do you think about renaming objects, because you are doing instance of doing rename of the same object?
But we are actually doing it. I mean, like, we're doing it anyway. At least in these demos, I've maybe I'll show that here in the code. Right. Sorry. Again, in this slide. Okay. So of course, instead of using this alias, I could go for like using this casting here, and then another parenthesis, and just times 2. But this is an alias, so I don't think it's anything bad. It's just because we might have many more calls here relying on this alias. So instead of having this line, I can just use this alias here. So I see no reason why we shouldn't be using this alias or this alias, because this JEP actually is about making this alias like easier to use and not to use any alias or rename at all. So I don't know if that answers the question, but this is like, it depends, right? Sometimes you can just go for something like this times 2, but many times you want to have the alias anyway. So that's it, I would say.
Okay, so that's the only question, is this in this JEP? So
all right, so let me go for sealed classes. Okay. All right, it's been almost an hour. Let's try to speed up, perhaps. Okay, so what are sealed classes about? They are preview features. So we have second preview in Java 16, meaning maybe we'll have that as a standard feature in Java 17. And this is a JEP for this, of course. And now we need to, like, there's another difference, because we had these access modifiers in Java, or we still have them. They're not going anywhere. We have public, protected, we have package default, and we have private, right? It's just they are responsible for visibility, and in previous versions, and even still, because the contract doesn't change, they are also responsible for extensibility. I mean, if a class is private, you cannot see it and you cannot extend it, right? Something like this. It's just sometimes it's a bit different. It's a bit more convoluted because, for example, as a library maintainer or library author, or I don't know, you just an author of a piece of a module like core domain or something like this, you want your classes to be perfectly visible for everyone. You want to make these classes public, for example, yet you don't want anyone to extend these classes but you, okay? So you have to go for a public class because there are some reasons, for example, and you can't go for a final class because, for example, you need to, or interface, because of course interface cannot be final. But for classes, you like to go for something that's not final because, for example, you'll be needing to specialize subclasses, but you want to make sure only you can create them, not anybody else, right? So it's about making to like these concepts or these properties of classes like orthogonal ones, okay? So visibility, or rather better said, extensibility doesn't depend on visibility only, okay? And this is exactly the case when we don't want somebody else to extend our classes or implement interfaces, because actually the full name of this job should be like sealed classes and interfaces. It's about sealing classes and interfaces. It's just everybody keeps saying sealed classes and it means classes interfaces, so just keep that in mind, please. And it's when we don't want to use this nuke option final, because final, it's like forbids everybody, okay? But here I don't want somebody else to extend my class or implement interface, but I want to be able to extend them or implement them myself, right? Because I need to create this hierarchy or this tree of classes due to whatever reason. And we cannot, or we don't want to reduce the visibility from public or to make classes private or package private, okay? And this is mainly to prevent bad or unintended code reused by inheritance. And I can't stress it enough, I think, because many people keep saying that inheritance itself is bad. I don't think it's bad. I think it's terribly misused, because object-oriented programming relies on few principles, and two of them are composition and inheritance. And it's not like a war. It's not one versus another. It's just, or one is always better than the other one. It's just they have their like use scenarios, and when something has something, you should go for composition, and when something is something, you should go for inheritance, right? It's just you can't go for bad inheritance that something is something having something else, okay? Pretty much like, I don't know, JUnit 3 or something else with these base test classes or something. So please remember, inheritance, according to me at least, it's not bad itself. It's used in a bad way, basically, many times. And that's it. So this is the case, right? So it's it's a UML diagram, and let me analyze this diagram with you. I should move to this side, I guess. All right. So this is the library, right? So this is like basically the library we like to ship, or we want to make some people to be able to use, and this is the user code or user land, shall we say? And I have a library type, and I want to allow this gray arrows. So my library type, I want it to be able to be implemented by this abstract lib type implementation and this no-op lib type implementation, because why not? And then I want this type to be implemented by two more specialized classes, and this is my like type hierarchy due to whatever reason, right? This is like a totally artificial and dummy example. And I want my users or the callers of my code to be able to go for these blue arrows, so they can use my library type, for example, as a parameter type, also as a return type, also as a field type, because why not? So they can contain, or they can see that type because the type is, for example, public. What I don't want them to do is I don't want them to be able to extend any of these classes. So I want my hierarchy to be sealed, okay, so they cannot add anything else on their own. It's just I want them to be able to use it only. So the green arrows are for myself. The blue arrows are for legitimate usage by users, by the callers, and the red ones are the bad ones, the not permitted ones, the ones outside this sealed scope, basically. And this is how we do that in Java now. At least in Java 16. So as you can, and this code, this diagram is reflected in this very code we have here. So I have this library type interface, see, and I'm sealing it. I'd say it's sealed. And then I need to enumerate explicitly, except one case, we'll get to that later. I need to enumerate which classes or interfaces are permitted to inherit or extend this interface. See, so I say that this abstract implementation is permitted and this no-op implementation is permitted. And then this child class, see, this class is sealed again. It's sealed itself. It's implementing this library type and it permits its children to extend it further, right? And then, of course, we have still final. The final isn't going anywhere, and the final is going exactly the same way as it's working now, right? So the final is like sealed, and I'm ending the inheritance here, like nobody's able to inherit from me. So this is it. And there's also another option, like going back for the default thing, which is not final and not sealed. I mean, various classes can go for non-sealed, right? And it's like a new indicator, meaning that, okay, this type can be like implemented or extended by user classes as well. And it means that something like this won't work, okay? Because when the user declares their type, okay, they cannot extend this type because this type is sealed and it's not permitting this type of theirs to be extending. Okay, so I mean, it might be complicated when I say it. I mean, sorry, English is not my mother tongue, but nevertheless, it's also illegal to implement this library type, right? See, this library type, it doesn't work. What works, for example, is using these seal types as field types or as a parameter types, or I could use that here, for example, for a return type, right? That would be something legal. And we should have code for that as well. Yeah, we have this sealing example, and yeah, we have this library type, and this is it, as I have told you, right? So this is exactly this code, and see, when I try to uncomment it, it doesn't work, and it should give us two errors because this type is not allowed here to extend this class, and it's not allowed to implement this interface, right? But this is legal. This is still permitted. So that's it. And yeah, as I have told you, you can go for a non-sealed if you want to open. I should also have an example of non-sealed. Let me see where maybe I'll find something. No, not this shape. No lambdas. It's sorry. It's more. Should be here. More complicated example of non-sealed. Yeah. So I can also have a non-sealed class. See, and then I go for this sealed interface is, as you can see, sealed, and it permits also sealed, non-sealed, and final. So when something is final, of course, it doesn't need to go for sealed or non-sealed, right? And when something is also sealed, then it should permit its own descendants, right? And when something is non-sealed, it means it goes back to defaults as we know it, okay? So then it even cannot use permits anything, because permit is now illegal, because this is, permit or permits, yeah, because let me even try to I mean, we could use an identifier, but it doesn't work. It won't work anyway because this type is non-sealed, basically. So yeah, that's it. And sealing. So it's because we have the concept of sealing also in other JVM languages, and I'm talking about Scala, for example, here. And there are slightly, or maybe not slightly, they're kind of a different rules when it comes to sealing in Java, right? So permitted subclasses need to be closed, and in Scala, it means they need to be in the same source file. I mean, the same file with .scala extension, okay? And in Java, when we have this .java files, it means that we can have only one public class, and maybe you want to have that, like, I don't know, a few classes, a few public classes sealed in a single hierarchy. And what then? So it means that the permitted subclasses need to be close, right? Close to the one sealing one, and it means if we are using modules, they need to be in the same module. So I have a demo here with this sealed module. And when we are using modules, I can have final events, which is like final, and it extends this also sealed, and this also sealed is in another package. See, so this is another package, and this is another package, and it's working because I'm using modules, and I have this module info descriptor, right? For everything. And when I'm not using modules, see, I don't have this module info descriptor, then sealing works only for the very same package and not for anything like sub packages or packages under my package or something like this. No, then it won't work. So if we're not using modules effectively, when we're using a unnamed module, then they need to be in the same package, or they can be in the same source file. And there's one nice property of being in the same source file, and let me show you here. We should see that. So when it's in the same source file, then I don't need to use the permits clause. See, and everything still compiles. So this is one of the changes from between the preview features, right? So if these types are in the same source file, and of course they can't be public, then I don't have to list them. But if they are in a different source files, then they have to be listed in a permits clause, right? Okay, yeah. So sealed classes must list, or interfaces must list their permitted children unless they're in the source file, and then they get inferred. And of course, this applies to interfaces and to records as well. I mean, records working with sealing really nice. I'm not sure if I have something like here. Yeah, sorry, no, it's a different example. Or it's used for casting check, or should be used in the future, right? Or is it used? Sorry, now conversions. Yeah, this is the example. Sorry for that. Yeah, so we have this interface and class, and basically, what does it show us here? It says, come on. It basically it will be able to say, well, for example, when we have sealed class, and this sealed class is used or under this instance of check and so on, then the compiler will be able basically to infer more when it comes to all these checks by instance of, and most probably in the future it will be also able to check more when it comes to pattern matching, when we'll see like a proper matching, for example, with switch expressions and so on, because then we may not need this default clause. Okay, just like we have enums, for example, when we have 4 values in an enum, excuse me, then of course we don't need this default clause because the compiler knows the check was exhaustive. For example, and this is the idea also we'll be using for sealed classes and interfaces, and it's check as a runtime too, meaning we cannot create a class or subclass of a sealed class at runtime. It basically won't work. Okay, and we can check if a class is sealed using this is sealed method. Yeah, so it will get us Boolean, And there's also a new method as well. Get permitted subclasses. So it gives us an array of classes which are permitted in case the class or interface we are examining is a sealed one. Right? Okay, so let me check if we have anything more. Sealed subclasses. Yeah, so this is what I told you. It must extend directly. That's important. So it's like, it's not like feudal times or like inheriting or child inheritance or something like this. I mean, the permitted class needs to extend the sealed class directly. It cannot extend like a middle class or something like this. So like I don't know, a grandson inheriting from a grandpa using, I don't know, like a mom or dad. It won't work. It has to be extending or implementing directly. And sealed subclasses must be either sealed, non-sealed, or final. So sealed, it means they are sealing their descendants as well. Final is, of course, it means I will have no children. And non-sealed, it means I'm opting out from this sealing concept. I'm going with the defaults, right? And that's also important. They cannot be anonymous or they cannot be lambdas, quite logically, I would say, because, of course, lambdas don't have names, or anonymous classes don't have names. So how can we check if it's running, right? So when I'll try to do something like this, it shouldn't work. Let me check. Lambdas won't work here. It's I think when we go something like this, permits, then see, it's fun to see. Anyway, this I leave this example for you because I think we are running out of time and we have quite a lot to cover. So will be used for checking exhaustiveness, and pattern matching. We'll cover that. And they can be less visible than a super class. That's also important, and that might be nice for some library maintainers. I think we have quite a few questions regarding this.
Yes, we have.
Oh my.
Let's start with the question from Łukasz. Can a sealed class subclass be a sealed class?
Yeah, perfectly. I mean, at every level of inheritance, you are free to or in fact, you are forced to say, because if you are a descendant or if you're extending a sealed class on interface, then you need to explicit yourself if you are sealed, if you are non-sealed, or if you are final. This is how it works, and it's unavoidable. I mean, you have to choose one of these three. Right, and then if you go for sealed, then this story applies again, like permitting valid subclasses or interfaces and so on.
Okay, so there is a second thought from Bartosz that it's good for libs, like you just show, but I just think that it's not only for hiding internals from users, but also in Scala environment, it's often used to, for example, generate schema from sealed class. Like here we can notice that there's the method get permission subclasses, right? So we can use this to just generate union types for GraphQL or Avro or something like that. So we can do a lot of things thanks to that. It's not only for library creators.
Yes, and I would say it's like even like ordinary developers can use that, because it will bring us the exhaustiveness of pattern matching, right? So then we will be able to get rid of all these defaults, or the compiler will basically tell us that we are covering all the cases that need to be covered. And so it might be even better in the case, like, you have like a piece of code that's, I don't know, doing something like, I don't know, a chain of if statements, for example, right? And we are doing something for type A, something else for type B, and something else for type C, like a different visiting or something like this. And then somebody implements your class or interface, and then you don't have it in your check, and basically things go wild, So this is about this, right? So sealing classes in interfaces is about like this exhaustiveness. I would check. So you are like then we don't even have to use like any third-party tools used for at continuous integration or as Maven plugins to make sure that we don't want anybody else to extend this type. Now it's a part, or will be, because still it's a preview feature, a part of the Java language and Java compiler itself. So it will like not only protect using invisible types, it will also protect bad inheritance or unintended inheritance of types which shouldn't be extended.
Okay, we have one more question just show up.
Okay.
Does explicit listing of permitted subclasses also prevents inheritance inside same file?
Good question. A good question. But by the way, I think I can do that on the way. So I think I will grant Bartosz one of the free tickets, and I very much like this question of Rafał as well. So I think that this would be a second ticket. Because this is like one of these. I mean, how we developers can twist things. So let's go for something like this, right? So let's say I'm not listing this type here, okay, and I listed only one. So when I start listing permitted classes or interfaces, then even if they are in the same file, it won't work because it says you're not allowed in the sealed hierarchy, right? So when I started permitting, then I'm picky, then I'm explicit about what's permitted or what's not. I mean, in terms of inheritance, of course. And when it's only when we permit everything, it will be permitted, or when we don't permit anything and the ties are in the same source file, then of course all will implicitly go here and work here because they are extending it, right? But when I start to permitting at least one type, the other ones won't work. Basically, I think it answers the question. Do we have more questions?
No, there are no more questions. So Bartek and Rafał just write to me on the meetup. I think it's the fastest way to catch up with me. So I will give you
or drop us
developers.
Drop us the DM or just contact us in a way. We can't paste it in the chat. Sorry, paste it in the chat, of course. Reasons it wouldn't work then, perhaps. Okay, so there are more changes. Let me switch back to the screen. There are more changes, like to ZGC, because previously the collection time of ZGC wasn't exactly constant. I mean, it wasn't like it was detached from the heap size, but it was depending on the number of threads or collection routes, right? And now it's no longer the case when it comes to ZGC. So now it's a standard feature, and now it means that there's like very, very little processing in this stop the world pauses, and the stack thread processing is moved outside, right, to a concurrent phase, meaning that ZGC now is processing thread stacks and during as a concurrently, basically in a separate thread, not during this stop the world pauses. So basically all this per thread route processing is removed from save points. There's also a promise that now it should be less than 1 millisecond. I think we've run a nice experiment for these in the past, so I won't do that again. Another JEP elastic metaspace. Again, it's a standard feature. And there's a switch. I think balance, if I remember correctly, is the default one, and we can go for aggressive and none. Basically, now the elastic metaspace or the metaspace is using new algorithm for memory allocation. It's using the one I I think it's used in Linux kernel or something like that, and it's body memory allocation. So it's like dividing by 2 and so on and so on. I mean, there's a nice description on Wikipedia how it works. It's just using this algorithm made like giving the memory back from the metaspace to the operating system much easier. So that's why a metaspace is now divided in different way, and it can give the memory back to the operating system, as you can see, even quite aggressively. And it means less class loaded overhead. I mean, it's maybe for most of us it's maybe not even that important, but if you are class loading and then unloading stuff quite frequently, then it means that you made quite a use of this new elastic metaspace, and of course it's also reducing fragmentation. All right, packaging tool. It's a standard feature now as well. We've seen at least 2 incubators, and it's a module. It's a new module, and it's not in a Java language itself. It's not called by a Java compiler. It's meant for building so-called native packages for different platforms. So I'm broadcasting for you using Ubuntu Linux, or basically a Debian based one, or Debian derivative. There are also I don't know if RPMs are still in use. We have MSI files for Windows. We have something for Mac, and so on. So the idea is that many people are not as tech savvy as us developers, and they are not like capable of installing Java and running the jar file we send them, even using java-jar and so on. So they rather have kind of like installer, right? So install their like our program at their machine, something like apt-get and so on, or yum install or whatever. I mean, something like this, right? And this packaging tool is about creating these native packages using tools provided now in JDK itself. And one of the constraints is that there are no cross builds between platforms, right? So if I'm running like Debian, for example, I'm only able to create deb files, not MSI files, for example, for Windows. Okay, and I'm not even sure, but I think for Windows it even requires third-party dependency. It doesn't require or shouldn't require anything on Linux, and it doesn't have any GUI or wizard or splash screen. It's a CLI only tool, right? So it just creates a package which can be installed in CLI. There is a short demo, should be a short demo in a README file. Yeah. So let's go for this brief demo, right? So let me switch to another terminal here. Yeah, we just let's make that a bit bigger, and let's paste it. So I'm now creating a package, right? So I'm creating a package, meaning I should have. Oops, it doesn't work. Why it doesn't work? Yeah, because I messed here. Sorry, I messed here. As you can see, yeah, lambdas don't work here. And if it's not called by IntelliJ, then it's called by the compiler, right? Because it's not a functional interface and so on. And Cylic doesn't work for functional interfaces. Sorry, I should go. I'm covering that. So let's go for the screen only. Yeah, so because this func wasn't or is not a functional interface, that's why I had to roll back this change. So let's try to package this again. Okay, and now we should have 3. Where is it called? Or where is it? It's 3. Sorry, like let's go for goodies, or what am I using here? Records. Yeah, okay, so let's go for records, and then target, and it's in target I have this jar file, right? And normally this is what we use, for example, when we want to run on for example, using just java jar, for example. And let me now copy this to libraries directory, because what I also have here is in libraries I also made downloaded all the dependencies, right? So we are not having a fat jar or uber jar here. I just have a slim jar or regular jar with and then the dependencies downloaded like separately. And now I can use, or should be able to use, and let's pray to demo gods, to use the J package, meaning I'm creating a J package with this name, and this is my input. So see all the jars in the lib directory, and this is my main jar. So the jar I just copied one step before, and this is when I want it to be generated. So let's wait a few seconds more. Okay, and let's see how it works now. See, and now I should have, and I have this deb file, right? Meaning I can now go for a apt install with this deb file. Okay, so this is what J package is about, I think. And of course, it has more switches, more quicks, and so on. This is like the super duper most basic usage scenario. Okay. Do we have any questions regarding this section or previous ones?
No, there is not.
Okay, no questions. Okay, so let's go quickly for Panama project, which is about this native stuff. Okay, right. So we have this foreign memory access API, which is an incubator module, and it's a third release, and we might see more actually, because the authors behind this are really experimenting a lot, I would say, or trying to make this thing as safe as possible and as robust as possible. There is a really nice job to read. Okay, so what is this all about? So basically, it's about, like, I mean, yesterday Jarek Pałka gave a like over 2 hours talk on just Panama itself, on Warszawa Jug. So if you're perhaps if you speak Polish, because it was in Polish, so it's kind of encrypted, you can follow that. I will try to cover that briefly, because we don't have that much time. So what this foreign memory access API is all about? It's about using the memory, mostly of heap memory, but also heap memory, in a way which is safe and efficient, in terms of performance. And so these parts related to using memory from SunMISC unsafe can be hidden or taken away, or basically covered maybe under the hood. So we don't have to rely on various quirks on SunMISC unsafe, or people like, I don't know, database vendors or other tools which really need to access the off-heap memory due to, for example, performance reasons. So this JEP, or this whole story when it comes to using memory in Project Panama, is about avoiding limitations of Java NIO byte buffer. And it should be safe, unlike SunMISC unsafe, and documented, because SunMISC unsafe isn't undocumented, I mean, at least officially, and should perform equally well as these two, and hopefully better than JNI. And how does it work? I mean, at least in this release, because it changed regarding previous ones, and it might change, in the future as well. So we have a thing, or a concept called memory segment, right? So this is a link to a Java doc. If you need more, and I think you should try to study it if you're really eager. So it's like a memory region which is bound, and these boundaries are basically in 3 dimensions. So it's like in space. So basically, unlike, for example, C, we can't exceed the memory, okay, or can't go beyond the bounds or the limits, or the, I don't know, the reserved size, something like this, okay. It's also bounded in time, because we can, for example, very nice use it with try with resources, or we can call a close method manually, and then it means it won't be able or it won't be usable after that. And it also is bounded, at least by default, to a thread. So when you create a memory segment in one thread, and in order to make other threads or other thread be able to use it, you just need to hand over it to another thread, okay? Or you can create like a shared one, but then there are more risks basically. It also has, I mean, this whole memory access, another building block, which is memory access, memory address. And it's really nice if you'd like to model an address received, for example, from a native SQL or another, I mean, C call or C of the language, not SQL like for standard query language of a database. And it should model an address like when we receive this address from somewhere else, or it could be like a starting address for a memory segment, for example. And there's also a memory layout, because instead of going or computing these offsets or locations of the pointer by our own, we should be able just to rely on this memory layout. So we can say, for example, this is my segment. It has such a layout that I'm storing there, for example, longs, and then I should be able to like give me, I don't know, the fifth element. Okay, so I don't need to compute which byte is this and then ask for, I don't know, starting this byte and this offset give me that many bytes. I just say give me the fifth element, and that's it. And it's possible to do using this memory layout. And var handles from Java 9 or 10, I can't remember precisely, they can be used to store and fetch, and maybe more will happen here in the future as well. So let me go for a quick demo. For a memory access API. Yeah, okay. All right, so let's just run it first quickly. And will it work or won't it work? Yeah, it doesn't work. Why it doesn't work? Because it's not aware of such class. It says no class definition found. So please don't forget to add this module, okay? When you run it. Yeah, again, it's a VM option. All right, and let's try to rerun it. Now it's working. So what it does do, it's quite simple. So we have a single thread, and I have this memory layout. So I'm saying that I want a memory layout of sequence of 10 and then 10 word, basically 32 bits in native order of this very machine, little endian, big endian, and so on. And then when I have this layout, I'm just saying to my memory segment, please allocate it using native memory, meaning off heap, and then I can populate it, and then I can examine what's inside, okay? And I'm passing this layout, so when I'm populating, I know what's inside, all right? So I know, and I'm basically saying that go for each element and store a subsequent value. Basically, as you can see, I'm going from this 0 element to the element count, and I know this element count how much I do have because I have passed this layout. So as you can see, I have, and then I can set something at offset, okay, or I can set something using this var handle, something like this or something like this, okay. So I don't have to compute even this offsets. I can go for just setting in this segment, please set this element, as this element set this value, okay. So this is what I can do basically. As you can see, no computation of various offsets of anything like that. And then examining is quite simple. I'm just going through again. It's just this time I'm getting this element. So better said here, right? Oh, see, I'm getting this element, or like this way or this way. That's why I have two values here. And you can also see that this segment is owned by, and this is the name of the thread, because this segment has owner thread, right? So this is to make sure that by default, at least by default, if the segment is not shared, there are no two threads trying to examine it concurrently. And when I try to do something like this, see in this two threads demo, see, this is it. I have this handoff here, right? So I've created a reader thread, and this is like an alias. This creates another like an alias to this segment because of this handoff, and this is now like owned by this reader thread. And when I try to examine this segment again, it doesn't work because this segment is already closed. Okay, basically it was handoffed and so on. And also I have this here, this examine and close, meaning after this thing started and so on and so on, it's I mean, even this alias is closed, and this one is closed here. Not sorry, it's not, because I'm not using it with try with resources. So as you can see, it's bounded by the space, by the time, and by the thread. So this is, as you can see, to make the usage of memory, of native memory, basically much easier and still fast and efficient. I think we'll group that with this foreign linker API. So foreign linker, another thing from Project Panama, is also incubator module, but the first one, this one, and it's like a twin brother or sister or just a sibling, like close sibling of this foreign memory, because they really depend on each other. And it's about like replace this JNI when we want to like make a call of a native stuff with pure Java model again. So make it safe, to make it like strict with types and so on and so on. And so far it's supported for C on 64-bit architectures only, but in the future we might expect like to be extended for C++ or x83 architecture and so on, or possibly maybe other architectures as well. And again, its performance should be at least as good as of GNI. And it relies on a concept or a new type, which is C-linker. Again, Javadoc, my friends. And what C-linker does, it allows basically two things. It allows so-called down calls and up calls. So a down call is something, or it happens when I'm calling, for example, a C code from Java. And up call is the opposite way, when the native code is calling a Java code or Java method. And then of course it's how it works. It's like it creates stubs with method or function pointers and so on and so on. It's a nice piece of engineering, how to make it reliable, immune to garbage collections and so on and so on. I should have a little and simple demo for this. So see, I have a CLang library installed here, and let's pretend we don't see this 10, so we don't know which version is this. And maybe for you it will work with this default. It depends on your setup. If you don't, if it doesn't, you can install libclang for your system and just replace this with your path where it actually is located on your machine. And then you see I have the C-linker, I get instance, and then I'm calling, making a down call handle, meaning I will call this something from this native code, or I will make a native code from Java, right? And what I'm going to do is I get method handle, and because from the list sibling, I'm going performing a lookup of this method, like this, function, functions in C. So I'm going to call this function, and if you go for a documentation of this function, it clearly says that it will what it needs. It's like there are parameters it gets, there's result type it gets, and then when it gives something as something back, for example, that we can get it as C pointer, and then from this C pointer we can get this again and see this is this memory address, like a result of this call is somewhere in native memory, and then we wrap the result in native memory. That's why they are close siblings, to a version string, and I print it because now as you can see, it's maybe I should go like this string. It's a string, like a proper Java string, not a native string. Let's see if it works. Yeah, it works. See. So this is the version of my CLang. right? So this is basically what this linker is about, at least when it comes to downlink calls. So from the linker, I get an instance, I create a method handle providing like a return type and return type and parameter types, and then I can do something with the result. I can also provide it, I don't know, with more pointers and so on and so on. I mean, this is like a huge beast, and it's really like the simplest demo I could think of. Do we have any questions for that? I don't think so.
No, there are not.
Okay, so it seems that there are not so many folks interested in scratching metal with bare hands. Maybe that's good. Okay, there's another thing from Project Panama. So it's again an incubator module, and what does it do? It's about this vector computation. So it's about providing a platform agnostic API. So it doesn't depend on the CPU you have or we have in our servers or other machines. Currently, it supports only these two architectures, but it might change in the future again, and grow, of course. And in theory, it should use the SSC and AVX extensions of our processors, if that's applicable. It's just it shouldn't be done like it's done now, under the hood. For example, when we call a system copy array or something like this, it should be like creating this agnostic API, which we are able to call directly, right, without this code being like let me say, like, I don't know, replaced or smuggled under the hood at runtime. Okay, and of course it should degrade gracefully where not available. And gracefully, it means if there's a given processor some instructions aren't available, some vector instructions, then not everything is going or falling back. It's just there's a placement for this missing instruction. And maybe we should just go back for this vector. And so it's built around this vector, but please keep in mind that this is a new vector and its subclasses. And what's this vector in vector computing? Let's say, the simplest case I can think of is, for example, we have two arrays, right? And each array has, for example, 1 million elements, and we have two arrays, and we want to summarize these arrays in a way that the first two elements, the first elements from both arrays should be stored in as the first element of a third array. So like x0 plus y0 should be z0, something like this. And then we repeat that for the second element of index 1 from both arrays, then the third element of index 2, and so on and so on, right? And the naive approach is to go for a loop, right? So we do that in a loop. It's just our processors using these SSC or AVX instructions are able to do that using these vector extensions are able to do that in a way of chunks. Let me put it that way. So they can just, it's like, implementation of this single instruction and multiple data, SIMD paradigm or architectural approach, something like this. So it's just fed with data, and we call a single instruction. And now we should be able to do that in Java as well using this explicit API. And it should be particularly useful if you are in machine learning, like linear algebra, banking, cryptography, and so on and so on. And of course, it could be used by JDK itself. And again, it's about explicit use, not under the hood, like improvements at runtime. And it's like it's that this vector API should benefit significantly from value types. So the value types or value-based types from Project Valhalla we were discussing at the beginning, because then these objects or classes, we will not have these headers and so on and so on. So that should be faster. One more thing to cover today, I hope, is Unix domain socket channels. I don't know if you know, but at Unix you can also have other sockets, not only TCP IP sockets, but also other sockets, which are these Unix domain sockets, right? These are local sockets, and local programs can write to them. And apparently, I didn't know that Windows now supports at least a subset of Unix domain sockets, Windows 10 and latest release of Windows Server. And now it's a standard feature, and it's introduced in this JEP. And we have a new class, Unix domain socket address. So I should have a demo as well. Let me go for that demo. Yeah, so this is the demo. And let's say I have PostgreSQL running here. And I want to make direct use of this local Unix socket, because first it's local, and second it's more efficient. It doesn't use this TCP overhead, right? So let's run this, and kaboom! It doesn't work. Why it doesn't work? Because I've tried to go the naive way, right? So I wanted to create a socket, just a regular socket here, just a socket, and then connect to this address. And when we go here, you can see, or we should see it's checking the type. And if the type is not INET socket address, then it's throwing this exception. So it's not about making regular sockets being able to use these Unix domain sockets, and it's about these socket channels, you see, like another reactive access to database and stuff like that. So it's important in your code that now it's that there are more kinds of socket addresses. So previously we had only this INET socket address, and now we can also have Unix domain socket address. So see, this is where we could use seal types, for example, because we had 2 types and nothing else. And it works on Windows too, although there are some limitations compared to Linux and Unix. Yeah, and it's support for these Java NIO channels, not for regular sockets, as you just saw. Do we have any questions regarding last sections? Because, sorry, my chat is really, really small.
No, there is no questions.
There are no questions. Okay, so I think we'll keep the rest for the next meeting, namely records and a few smaller things. Okay, yeah, okay. Sebastian is doing a really good job as a media producer. Remember, my friends, to always, and for everyone at every like meetup or conference or a presentation, to always provide you feedback in any form. I mean, this is not the best time to send postcards, perhaps, but you can fill this little poll. I mean, this poll is really, really small. As you can see, it's anonymous. We won't have your name. I won't have your name. Just let us know, folks, how this worked, how you think it was, if it was okay, if it wasn't okay. Maybe it was a bit too fast, but see, we're reaching 2 hours, and I really wanted to make this one small and the next one as well, so we don't reach, like, I don't know, 3 hours or exceed 3 hours. So the next time we'll be talking about records and other small things that Java 16 brought to us, Java developers. So please fill this poll. And by the way, it will keep working even if you're not live. So if you're watching it later, please fill this form as well. And this is it for today, I believe. And the slides, the code, and everything is here. Do we have? I don't think we have any more questions. So Sebastian, it's, I think, as the organizer, as the CEO of our Jug. Yeah, it's
my time.
Yeah, this. If you have any more questions, and you have still one more entry for developers to give away.
Yes. Okay. Yeah. We will check the comments from this meeting and choose one of you, and I will write to you on the meetup. So please sign up to the meetup. It will be so much easier to find you, not to searching Twitter, LinkedIn, and so on. It's hard. Thank you, Piotr, for coming here. Thank you for doing this presentation once again, because it's kind of our tradition, your presentation about new Java features. If you want to meet Piotr and to talk with him and I don't know, eat something and drink a beer. So when we will on site doing a JUG Wrocław, come, and it's really amazing community with great people. So yeah, that would be great if you would come, a lot of you. And again, thank you, Piotr, for coming. It was a pleasure.
Okay, yeah, let me just comment that I really hope this was the last Java version I'm showing like remotely. Hopefully the next presentations on next Java versions are going to be like real, so we can, as you have said, meet each other, hug each other, and toss a beer and get a proper haircut before.
Yeah, we all hope that. Okay, thank you, guys. Good night.
Thank you. Bye-bye.